There is always a fair amount of interest in my treadle hammer here at Black Bear Forge, so today I thought we would look at some treadle hammer tooling. And the reason I thought we would look at that is because I got this box from Blacksmith Supply yesterday, and in this box was this very interesting pair of tongs and a note. And the note says, "John, here's a pair of tongs designed by Mike Boone of Colorado." I know Mike, or I have known Mike. I haven't seen him in probably 10 years or more, but he's a very talented smith. His father was a very good smith. So blacksmithing is something that kind of runs in their blood. In fact, I've got another pair of tongs that were made by Mike Boone that I bought at a conference quite some time ago. The slotted jaw tongs people ask about a lot. So Mike has some pretty good ideas. Anyways, we are providing them now. Great for treadle hammer work. So what is it that these tongs are made for? It doesn't actually say, but I think it's really pretty obvious. These are tool holding tongs, and that means that you can hold tools that don't have a handle on them, that you wouldn't want to get your hand down close to hot work under the treadle hammer. And you can hold them in here. You could even use these at the anvil for holding various tools. And it just depends on the tool you need. But most of the tools that I have that are short that I'd want a handle on aren't real heavy tools. These are tools I either use by hand under the treadle hammer as it is, and I just put a stop in, and this is for cold work, which is what most of these are for, or they're tools that I use cold at the anvil or over here at the bench. And I don't think I want a handle on really long tools because I don't use them under the treadle hammer. There's not enough height to get a good swing with the treadle hammer. But tools this long aren't so bad under the treadle hammer. They're just a little bit light duty if you're really wailing on them. So with that in mind, I thought we would make some heavier tools. And this is one I made this morning just to try out the theory. Made out of S7. And that's a 1-inch diameter bar. So that's 25 millimeters in diameter. I cut a piece 3 inches long, and that resulted in a tool that's about 4 inches long. So that's a cut length of 75 millimeters, and I end up with a 100 millimeter long tool out of that. And part of the reason I could end up with that long tool is because I'm forging this reduced area where the tong index is better. And that keeps this from slipping out vertically, otherwise the tongs are going to kind of move up and down as you use it. And that is a much more secure grip with this, and it makes for a more ergonomic grip here. In fact, I may need to reduce it just a little bit more to bring these in some. And I have seen people that do this under the lathe. They just go ahead and turn this section in, but to do that you're going to need a tool that's a little bit longer. I'm getting a 1/2 inch of stretch as I forge this. So if I have a 3-foot bar of steel and I make 10 of these tools because I'm using 3.5 inches per tool, by forging them I can take 3 inches per tool, end up with the same length tool, and I get 12 tools out of it. So forging can be a little bit more economical, especially if you're buying kind of expensive tool steels like S7. But if you'd rather turn them on a lathe, go right ahead. Now what I did do with my little blank of S7 here is I turned just a couple of tiny grooves on here, and that's just enough to index this under the guillotine tool, and most of that drawing out of that reduced area is done under the guillotine tool, and I think that is a highly appropriate tool for this job because my guillotine tool is the Smithin' Magician. There's no G in that, it just ends with an N. And the Smithin' Magician is currently being sold by Blacksmith Supply. So this is where you would go to buy this tool. I bought mine from the Blacksmith's Journal, who is the original designer of the tool. They used to sell them. But now you got to go to Blacksmith Supply if you want one. They sell the tool in kit form, finished tool, a variety of dies. It's been a really good tool and I can highly recommend it. But today, the topic is making these little set tools for use under the treadle hammer. And the first thing we're going to do is use the butcher dies and butcher in to create the shoulder that will be this reduced area for the shank. And to do that, I'll just index my little grooves that I put in there earlier and butcher to the inside, so I have to turn everything around to do the opposite side. That should give me a nice clean shoulder to work with, and I'll use these other dies to refine that shoulder. So we'll just start with that shoulder. Index that in our little groove. Don't go too deep here. You don't want to create a weak spot in the tool. I'm just rolling it around. That's really all I need to do with that. It's easy enough just to turn the guillotine tool around to get to the other side, because you want the bevel into this shoulder. You get it going the wrong way, you'll be sorry, I think. Make sure it stays in the groove so you don't chop up the tool and end up with some sort of a cold shut. This S7 gets hard to work as it cools down because it's a air hardening steel, so it's hardening the whole time you're working on it. So I'm going to take another heat and deepen that just a little bit, not much. So now I've got my shoulders established. I want to start thinning out this center section. Ultimately, I want to draw that out to about 1.25 inches. I was 3/4 of an inch from the end to the shoulder, and 3/4 of an inch between my shoulders is what my layout was. Now we're up to about 1 inch, so I only need to get a little bit more, and then we should have a nice reduced shank there. To do that, I'm just going to start with a simple fuller. And this just helps draw it out a little faster. I'm not drawing out enough material here that I'm too worried about the typical square octagon round, although it would probably be better. I'm kind of just working it around. And that's just because I'm trying to sneak up on it and I don't want to get it too small in the square dimension and then still have to round it up. Throughout this whole process, just keep an eye on those original shoulders so you don't mess them up. Probably won't hurt the tool any, but it'll look better if you don't. And I think we're going to start working that down more as a unit instead of fullering, just to make sure we get it done smoothly. And for that, I'm going to start with just a regular pair of tenoning dies. The exact space between the dies doesn't really matter at this point because I'm not going to work all the way down to that. And again, make sure you stay inside your shoulders. Once you get this work down, you'll be able to find the shoulders at the edge of the tool. And then it'll be much easier. Now I can drag that back and I can feel that shoulder there. So that's making good progress. It's still a little bit large in diameter, and we aren't quite up to the point we want to be. You need to make sure that these outer jaws of the tongs index that whole thing so that they're all down in that groove. As we get a little bit closer to the size that I want here, I think I'm going to switch to a different pair of dies. This is just a set of swedges that have very nicely relieved edges so I don't leave a bunch of chop marks down in there. I would expect to need to do a little filing, grinding, or something on this just to get it exactly where you want it and make sure it's truly parallel. And it could still go down a little further. That's getting much closer. It's definitely going to require some filing up there at the shoulder. That's a little bit washed out. But I think that filing will make this fit perfectly, so I think we're pretty well done there. Now if you have a belt grinder that runs 1-inch belts, it'd be really easy to get in there with a belt grinder. You can also split belts on a belt grinder if you want to split a belt down to 1 inch or even 1.25 inches in this case to get in there with an unsupported belt. Most of us don't have a platen that's 1 inch, but maybe you got one of those too. Now another option would be to fully anneal this and just then clean that up on the lathe if you have a lathe. For me, what I'm going to do is heat it up, cool it in the vermiculite so it's as close to annealed as I can get. It's air hardening steel. It doesn't normalize in air, it hardens in air. And cooling it in the vermiculite is softer than fully hardened, but it is not fully annealed. At that point, I put it in the lathe, but I don't use the lathe tools. I just use a file, and it's probably going to wear out the file a little faster, but I can get a really nice shoulder by doing it that way. So I'm going to go do that, and I'll meet you back here. Well, we have our tool prepared, or a tool blank prepared, and if you're going to go to this kind of a system and use tongs like this, you might want to just make up, a half dozen or a dozen of these things to this stage. And then at this point, you can turn it into any kind of a tool you want. Now, earlier today, I made just a simple chisel, and that's probably the first tool I would make for a system like this. You always need chisels, and under the treadle hammer, they're really a useful tool to have. In the future, I might like to do more decorative work under the treadle hammer. And one of the tools I would like to have is a butcher. And making a butcher that kind of matches my handheld butcher would let me transition from the treadle hammer back to the anvil to do some finer detail if I need to, and I think that would be a good tool to have. So I think the next tool we're going to do is a butcher as similar to this one as we can get. I'm just going to start by drawing a square taper. S7 is tough stuff. I'm going to want to get that down to about what this is, and boy, it's close. So just a little bit more there. This great bright light right there is a hail hole in one of my skylights from last summer. It gives us a nice taper. And taper's ends are never perfect, so I'm going to start working this corner back to create that beveled end that a butcher needs. This allows that longer edge to become my long spot. Just seems more efficient. Take a lot of grinding one way or the other, but the closer you can get to finished size by forging, the better you'll be. And of course it had one corner that was long, so it's not going to be perfect no matter what we do. But that does get the butcher shape nicely established there. So let's go ahead and put a touch mark on there. I'll mark one side of this with my last name and the bear paw, my usual touch mark. And the other side I'm going to mark S7. I've got a stamp for S7, that way I remember what I made this out of, if I ever need to reharden and temper it for some reason. The next thing that needs to be done then is a rough grinding before hardening and tempering. Now, if your only option is to file this, you might not want to use S7. Since it's air hardening, it's kind of difficult to fully anneal it. You need an electronic oven. It's kind of an all-night process. You set it to slow cool, and you can get it fully annealed. It won't be too hard to file. But for most blacksmith shops, it's not something you have or not something you're going to take the time with. To do this on a belt grinder, it's fast, it's simple. It's only going to take me about a minute or two to do this. But if you're filing and that's the best option you got, you might want to use an oil hardening or water hardening steel. You can make these out of 1045, 4140, 5160, any of those things. I just happen to like S7, and I like the fact that it's air hardening because it's really quite simple to harden. Anyways, here's my rough grind. That's very similar to this other one. It's perhaps a little steeper, so this would be what you would refer to as a first pass butcher, and we'll talk about first and second pass butchers at some other point. But that's really all we need to do at this point. I'm going to go ahead and harden that. And S7 hardens at a very high heat. This is not one you can just bring up a little bit hotter than magnetic and then air cool it. It won't get hard enough because that is not critical temperature. This is way above magnetic. Critical temperature for S7 is 1700 to 1750, so somewhere around 1725. That's a fairly bright orange if you're just judging it by eye. And that's what I'm going to do today. I'm just going to judge it by eye in the gas forge. I'm going to heat the entire tool up, and then I'm going to put the struck end down in vermiculite so it cools very slowly, but I'm going to leave the working end out so it can air cool and harden. And that's all I need to do to that. Now that'll need to spend some time air cooling. The tip will cool down fairly quickly, but the part that's in the vermiculite may take a few hours to be cool enough to touch. At that point, I will put it in the toaster oven at 400 to temper it, and then I'll be able to do my final grind on it and make it ready to use, and hopefully still get some final images of it at the very end of the video, where I usually put the images of the finished product. But you should have the idea what we're going for. We're going for fairly simple to make tools, except for creating that reduced shank in the middle that will fit in these tongs. Now, how would we make those faster and easier? As I mentioned before, if you got a lathe, you can just turn this down. But I would start with at least a ½ inch longer piece of material because you're not drawing it out, you're not stretching it in the forging process. You're just removing material with a machine tool, and therefore you need more material to start with to make up for that. If you have a machine shop, you can probably do that in just a few minutes. It'd be fast, it'd be accurate, you'd be able to mass produce a whole bunch of these in a morning, and then just have them around to forge the ends. For me, since I'm not really machinist oriented, I've got the lathe, but I'm not really all that good with it, and I would rather use the more expensive S7 and get a few extra tools out of it. I think I'm going to make some power hammer tools for this. I think with the right selection of spring dies, I could draw this section out in just a couple of heats, and that'll be a future video to make those dies, try them out, and then once I've made a handful of these tools, I've got a project in mind that we'll do under the treadle hammer and look at how well tools like this with a pair of tongs like this can work and how versatile they can be. One of the big advantages is you save the step of trying to fit a handle to it, and they store easier because they don't have a handle. You can just take a 2x4 on edge and drill a whole bunch of little bit bigger than 1-inch holes in there and just stack these up in there, screw that to the wall of your shop somewhere. Easy, out-of-the-way storage for tools like this. And as you need different sizes, different shapes, not all that hard to make once you figure out how to do this reduced center section a little bit more efficiently. Heck, you could probably make some dies for the smithing magician that work better. And if you're working in something besides S7, it's going to go a little bit easier. S7 is hard stuff to work, so that's a little bit more effort to do all this in S7. If you were doing this in 5160 or 4140, it would go a lot faster. So thank you, John from Blacksmith Supply, for sending the tongs, and thanks Mike Boone for designing the tongs. We're going to get a lot of use out of these. We're going to explore the idea further. For everybody else, thanks for watching the video. If you enjoyed it, give it a thumbs up. If you haven't done so already, I would love it if you hit that subscribe button down there. Feel free to stick around, watch a few of the other videos, share the videos with your friends. If you would like to provide financial support for the videos here at Black Bear Forge, there are links in the video description for both PayPal and Patreon. Those are merely donations. The content is free. In the meantime, I hope you have time in your day to get out to your shop, make something, but stay safe, wear your safety glasses, and we will see you for the next one.